In this lesson, we're going to be talking about reverse engineering. Reverse engineering is the idea that you can take something and be able to observe it in particular ways and recreate what it does, or at least its functionality, so that you've got something that reasonably represents the original. So let's say I've got program A, and it does some series of functions. The idea of reverse engineering is I could take a look at program A and duplicate what it does in program B. So I'm not actually stealing program A, I'm just using it as a model for the program I am writing. Now, there are some different techniques for doing reverse engineering. Some of it is just simply observation. You can observe what a program does and be able to say, okay, so it does function X, Y, and Z, and these are things that have to go into my program. And so you could then go about writing these particular functions or features so that your program pretty well replicates what's going on inside of program A. Now, another thing that you could do would be to use something like a disassembler. So I've got a disassembler here, and I'm just going to disassemble a piece of code. And this is from the buffer overflow attack that we had used earlier. And I'm doing a disassembly on this binary program. And this is what the assembly language from this binary program looks like. So it's a file full of machine language. And what we've done is used a program to turn that machine language into human readable form, which is assembly language. Now, it's not hugely readable, but it's certainly better than what we had before. So here's the actual program in assembly language that was that buffer overflow attack program that had been demonstrated in a previous lesson. Now, you could use a disassembler to get an idea of how the program worked and take a look at the actual assembly language code and see what was going on. You could also use something like a debugger, and with a debugger, you could follow the flow of execution. This is along the lines of the immunity debugger and the Ollie debug that we had used previously. So here's a different debugger. This is GDB. And this is the GNU debugger, and it runs under Linux or Unix-like operating systems. So GDB is capable of doing debugging as well, and this is a command line program, although there are front ends that will work with GDB. But this debugger will allow you to step through the flow of execution of a particular piece of code and be able to understand how it works and what it's doing. And from that, you should be able to, or may be able to, determine how that particular section of your program should operate. So that's another way of doing reverse engineering. Now, you may find that reverse engineering is a bit of a questionable practice because there's the potential of violating patent laws and copyright laws, and you're really walking all over intellectual property, possibly. So you may find reverse engineering questionable. When it comes to looking for vulnerabilities and exploits, however, reverse engineering is sort of a critical function. So you've got to be able to dig down into the program and look very closely at what it's doing in order to find where there are a possibility of vulnerabilities and where those vulnerabilities have the potential of being exploited. So reverse engineering isn't something that's done on a regular basis by most IT professionals. It's not even done on a regular basis by a lot of ethical hackers or penetration testers. But for some people, reverse engineering, and particularly the ability to use a debugger in a way that gives them some deep insight into the program, that's definitely a skill and it's one that probably not a really large number of people possess. But that's reverse engineering.